Hi there. Welcome back to another video for the Idun cartridge for the Commodore 64 and 128. In this video I'm going to be demonstrating a new feature for the cartridge, and that's support for CP/M. So just by way of a quick demo and to get started, we're sitting here at the basic prompt after booting the Idun cartridge, and we'll press return. And at this point you would normally use a go command to launch probably the default shell, the Idun shell that you maybe have seen me demonstrate before in these videos. But instead of saying, for example, go DOS, which would launch that shell, we're instead going to say go CP/M. And we'll press return, and in just a couple of seconds, you'll see that we are greeted by a somewhat familiar looking CP/M prompt, assuming you've ever used CP/M before. A couple things to point out here right in the header. You'll notice this is called CP/EM, and the lowercase em is a hint that this is running an emulation. So this works on both the Commodore 64 and Commodore 128. It works with or without an actual Z80 CPU. And when you're not using the actual Z80 CPU, it's emulating the Z80 CPU. Thus the clever sounding name CP/M. Also, this is based on the Run CP/M emulator. So this is a project that's been around for quite a while, and which you can find on GitHub. A fantastic project. I highly recommend it. It's been ported to a number of platforms and processors in the past, and now it's been ported and enhanced for the Idun cartridge. So you'll see we're sitting there at an A prompt, or an A0 prompt, so we're at volume A0. And you can immediately type familiar commands for CP/M, dir, for example. We'll pull up a directory, and you'll see it comes up very quickly, and we have a bunch of COM files in this particular volume. One of the COM files is this sd.com, which stands for super directory. So you press SD, you also get a directory. I kind of prefer this. It's a little bit better format, shows you the sizes of the files and how much space is remaining, etc. And there's lots more familiar CP/M commands. But before I get into demonstrating some more of that functionality, I'm going to jump over to the E volume. So I'll just say E colon, whoa, that's bad. E colon, whoa. Sometimes it's hard to type while making a video. E colon. Press return. Now we're at the E drive. And press WS to launch the famous WordStar word processor. And we'll press D to open a document. And let's open this cbmcpm.doc, which I typed up a little while ago. And hopefully you've noticed by this point that this runs extremely fast. And this is mostly due to the fact that we're emulating the Z80. And really what you're seeing here is the fastest Z80 you've probably ever seen. With the emulation, I haven't benchmarked it, but I'm guessing it's probably like 100 megahertz Z80 equivalent. And plus you have very fast file access. And so everything's very snappy and kind of fun to use, which was kind of the idea, the thing that convinced me to add this feature. But anyway, before I get more into demonstrating the functionality, I wanted to talk a little bit about why CP/M emulation or CP/M support in Idun cartridge is something worth pursuing, worth using. What does CP/M really have to do with these Commodore 8-bit computers, kind of is a reasonable question to ask. If you know something about the history of the Commodore computers, you know that they were introduced well after CP/M, and when CP/M was already kind of a mature and popular platform. And they were introduced using a totally different processor architecture, the 6502. And so not inherently CP/M compatible or CP/M friendly. But right from the very beginning in 1982, Commodore supported, at least strived to support CP/M on their 8-bit computers. In 1982, they announced, and not too long after actually delivered, the CP/M cartridge product for the Commodore 64. And I think this was driven by a combination of maybe marketing checklist feature that they felt like they needed, but also some technical aspirations that I think were also in play. So on the marketing side, you can imagine you're introducing a brand new computer platform into a already crowded competitive market, and you're marketing it as a low-cost alternative, but also a serious computer that can be used for, business or productivity type of applications, but you don't really have any software yet to support those type of applications. However, CP/M already has very mature applications in these categories, mostly talking about word processors, spreadsheets, database managers. Those products were out there. And if you could claim that you supported those products, then you had a much more compelling case as like a serious tool for a business or productivity user, not just an edutainment, home computer, entertainment games, this type of thing. So I think that was the marketing aspect of it. On the technical side, I think it was kind of an easy sell for the engineers at Commodore, because one thing that you come to realize by studying these systems is that while the Z80 and the 6502 are totally different instruction set architectures, electrically they're not all that dissimilar. So if you've built a computer around either of those processors and you've created a system bus architecture and various peripherals and RAM, etc. on that bus, it's actually not that difficult to connect either one of these microprocessors up to your bus and then have a working full computer. So I'm sure the engineers at Commodore realized this, and I'm sure they thought, well, wouldn't it be cool if we could have both the Z80 and the 6502 connected to our system bus, and we could choose which one was active at any given time. So one would be controlling the bus, but the other one would be essentially halted. And then we could have two computers in one. And that would be quite a technical feat. And indeed, others were pursuing the same thing. Apple, for example, had solutions like this so that they could offer CP/M compatibility. And I think thus was probably born the idea to do a CP/M cartridge for the original Commodore 64. The product, however, was really deficient. And it wasn't because of this basic concept of having a second processor connected to the same bus and being able to switch between which CPU was in control. That all worked quite well. But there were some oversights in terms of, well, number one, disk drive compatibility. This was all designed to work with the Commodore 1541 disk drive, which is just nothing at all like the typical CP/M disk drive of the day. A proprietary system with different encoding, different controller hardware, different connectivity to the computer, just a very different beast. And so there was really no possibility that you were going to grab, an off-the-shelf disk at a software store that was selling CP/M applications that was for some other CP/M computer, K-Pro, for example, and be able to use it on your Commodore system with a 1541 disk drive. So that's a real problem. I mean, like, how do you if you're just a user and you just want to run applications, you really need some way to bootstrap this thing so that you can get your applications onto disks that are compatible with this system, because you can't just pull them off the shelf. I suppose there were technical ways that could be done, but I think it probably greatly exceeded the patience or the technical ability of the typical would-be user at the time. Just a lot of work. The only people I could really see maybe doing it would be somebody that was eyeing the Commodore 64 as a development system for CP/M, and maybe once they had a disk with an assembler on it, they could bootstrap the rest of everything they wanted to do to start creating their own software. And if they wanted to write their own CP/M software and save it to their own, Commodore diskettes, and maybe distribute those diskettes to other Commodore CP/M users, yeah, that could be a possibility. But for the typical user, it's kind of a non-starter. In addition to that, there was a serious display incompatibility in that the VIC-II only has support in hardware, at least, for 40-column text. And most CP/M programs expected and were designed to work with an 80-column terminal, kind of the standard 80 by 25 text terminal at the time. And so lacking support for that was another big detractor, a serious impediment to running the popular CP/M software that existed. And even on top of that, the performance of the system was not very good. So the product was, I would say, somewhat of a technical success in that it worked, kind of, but it was obviously a failure in the marketplace. So what did Commodore do a couple years later when they were developing the Commodore 128? Well, they decided to double down on CP/M support. And as Bill Hurd recounts, this all kind of started because they could not get the existing CP/M cartridge to work with the early development Commodore 128s, which is not surprising because the CP/M cartridge didn't work with newer Commodore 64s either. It, from what I understand, has some very tight timing constraints, something I can relate to, like different VIC chips have a little bit different bus timing constraints. And the read-write cycles don't always look exactly the same at the expansion port for every single computer. And this is something I've struggled with the Idun cartridge, tweaking it to get it to work with a wider array of VIC-II chips. So probably it had something to do with that, but in any event, it didn't work. And they wanted to be able to claim full backwards compatibility with the Commodore 64, and that technically included backwards compatibility with their CP/M support too. So Bill Hurd solved this by just adding a Z80 CPU to the system, and well, now you potentially had a much better CP/M implementation because it was built in. You didn't have to lose your cartridge port to this one peripheral, and it was already there. In addition to the built-in Z80, the C128 also brought excellent hardware 80-column display support. And so that solved another problem. And it also brought the 1571 floppy drive, which actually is compatible with typical CP/M drives. It's double-sided, double density, has the additional encoding support, hardware support to make it work a lot more like a CP/M drive and can actually deal with CP/M format diskettes from other systems. So they solved two really big problems, and congratulations. I mean, that's great. However, they still had a performance issue. It still kind of performed like a dog, especially when you're looking at it in 1985 compared to, by that time, other low-cost, faster CP/M capable systems. 1982, maybe this would have been a great CP/M solution, but by 1985, there was a lot more competition, especially in the low-cost side. And also by 1985, well, CP/M was pretty much waning. This was the time when a lot of the CP/M loyalists would have been trading in their trusty K-Pros for a compact portable. Additionally, it wasn't so much of a checklist marketing opportunity as it had been before, because by this time, at least the Commodore 64 had plenty of productivity software titles available for it. And the Commodore 128, shortly after release, would have many native high-quality software products for word processing, spreadsheet, this kind of thing. And to layer on all of that, by 1986, GEOS was on the horizon. So if you can imagine yourself, upgrading your 8-bit Commodore to a 128 in 1985, 1986, and you're hearing about this new GEOS operating system, I mean, this is the thing that's going to garner most of your attention. This is the thing you're going to want to, demo to your friends to wow them about how amazing your 8-bit computer still is in 1986. CP/M is not going to be the thing that you're going to use to wow your friends at that time. So you could say it was a valiant second attempt at CP/M, but it was too little too late. But it was there. It was on the box, right there on the box. It says, CP/M included. One of the three modes of operation is CP/M. So between the cartridge and the C128, CP/M is very much tied up into the story of the Commodore 8-bit machines. So it deserves that recognition as a place in history. It also deserves recognition just as CP/M itself. I mean, this was a historical operating system. It was MS-DOS before MS-DOS was in anybody's mind. MS-DOS obviously was inspired by CP/M. It was to some extent, just a clone of CP/M, and it was a very natural platform for the many CP/M users to move on to. So they didn't go to Commodore. They went to the PC platform, and they went to MS-DOS, and thus is the history. But it's a very interesting history, and if you can find the space in your heart to learn about CP/M nowadays and to learn about CP/M on Commodore nowadays, well, I think with this implementation, what the Idun cartridge provides is a fun way to do it. and we're all about fun here. So hopefully you didn't find all that discussion about the background of Commodore CPM to be too boring. And if you have other insights, please comment below. I'd love to hear your story about what you think happened with Commodore CPM and why it was or was not a worthwhile pursuit for Commodore to make. But to continue with the demo, let's just find our way out of WordStar here. So Control K and Q will exit without saving, and then X to exit, and we're back at the E prompt. Another very handy command is drives. So type drives returned, and it's going to tell you, well, you've got 5 drives available, A through E. And that's just because of the way that it's set up on the Idun cartridge. And indeed, I think you can have drives all the way up to P, and on each drive you can have multiple volumes. So if we use the vol command, for example, we'll say vol A colon, you'll see there's a total of 4 volumes on the A device, and it tells you what's a summary of what's on each of those volumes. If we just say vol with no parameter, then we're going to see that the E device just has the 1 volume containing WordStar 4.0. There are other internal commands like vol. If you just type question mark, then you'll see a list of the few internal commands. So these are built into the command processor. And one very interesting one you see there is Linux. I think this might be a first with CPM on the Commodore, that you can use Linux as a command. And this obviously because we're running in an emulated environment on top of Linux, running on the Raspberry Pi on the Idun cartridge. And so I can just type Linux and any Linux command. So if I type Linux ls, we'll do ls -l. You'll see the Linux version of the contents of the directory. I can type Linux pwd, present working directory, and you'll see that we're in our home Idun directory, and we're in the subdirectory under CPM. It's /e/0. So what that hopefully indicates to you is that, yeah, these devices are really just native subdirectories under Linux. Each volume is a native subdirectory. If I, for example, do a Linux ls, and we'll go up 2 levels, and then we'll do the A device, you'll see you've got volumes 0, 1, 2, and 3, just like I showed you before with, if I do vol A colon, there's the 4 volumes. So all of the volumes are just nested subdirectories, and that's how you can have a hierarchical file system with CPM easily managed from the Linux side. And that's how all the files are just vanilla Z80 CPM files that are deposited onto the SD card for the Raspberry Pi and available in this environment. So it's very convenient to use, and this all comes courtesy of Run CPM. Run CPM also eschews the idea of using disk images and just lays out the file system for CPM as native files within the native directory that the emulator is running on. So I hope that's clear, and I'll show you a little bit later how you can manipulate these files using a graphical environment using the web file browser. So there's a couple of different ways you can switch among the actual volumes. If I go back to A, so I'll do A colon, so I'm at A0, and let's say I want to go to A2 for Zork and other games. I can either do A2 colon, and that will take me directly to that volume, or I can say user2. So now I've switched to user space 2, and I'm still on the A device, so now I'm at A2. So 2 ways to get to the same location. And you'll see that user space holds. Like if I switch to the C device now I'm at C2. If I go back to A, I'm still at A2. So that's how that works. As long as we're here, yeah, you can see there's some games in this directory. Maybe we'll start this just to show how spiffy it is to run mbasic on a roughly 100 megahertz Z80. And so you get right into your game, which I don't know too much about how to play this game, so I'm just going to exit out of it. 3 X's, I think. And we can type Zork 1. And just that quick, you find yourself west of the house. And if you remember anything about being west of the house, you know that you don't want to go east immediately. You want to go south and then east. So now you're behind the house, where you can open the window and sneak into the kitchen. Yeah, fun times. So again, you see everything is really super fast, and this is the Zork 1 from back in the day, CPM binary, no changes, runs really fast, works great with the 80 column terminal display that the Idun cartridge provides. So it's fun. It's fun to use. If you like this kind of software archaeology, it's lots of fun. So continuing on with the software archaeology, let's go to the B device and let's do vol and see what we got here. Oh, Turbo Pascal, BBC Basic, DX4th. So if you were interested in programming back in the early 80s, part of the legend of CPM at the time was the broad support for different languages that was offered with CPM. I didn't have access to these types of languages on the trash 80s that we had at school, or certainly not on my Commodore 64 at home. But if you were fortunate enough to have access to a CPM system and all this great software, it was a really advanced programming environment for the time. So let's do user 0, and let's just take a quick look at Turbo Pascal. You just type turbo to start it. And so here you're at the kind of the IDE menu, if you can imagine an IDE for an 8-bit 64K computer. That's essentially what Turbo Pascal provided, and for a ridiculously low price at the time. I mean, it was so competitively priced. Turbo Pascal was awesome back in the day, the DOS version as well. But let's specify a work file. And we're going to open this my name program. So it loads that, shows it as a work file. And now we can go into the edit option. So press E, and there's our little program. And it uses actually the WordStar keyboard commands, control keys. So if you know how to use WordStar, then you kind of know how to use this editor too, which is great. And it's just a simple program, but what's really neat to see, leave out of this, if we just press run, or R for run, in the blink of an eye, it compiles it. And then what is your name? How about Odin? And then it does its thing, prints your name as Odin 20 times, I think. So not an impressive demo or anything other than the fact that it runs so fast, and you can obviously do much larger programs. And if you have any interest in Pascal from back in the early 80s, again, as a software archaeologist, this is a great way to play around with it. So we'll exit out of here. And go to the C device, use the vol command, and so the C device has a bunch of C related stuff. So we have the famous high-tech C compiler, Mix-C, and Manx Aztec C, which is special to me because Manx Aztec C was the compiler I used to learn C. My very first exposure to the language of C was with Manx Aztec C. So sample code for the ZCC cross compiler is a feature of the Idun cartridge. So if we do user 1 and we just pull up a directory of this, you'll see that there's some .c files in here, and there's a makefile. And the reason there's a makefile is because these are designed to build with the cross compiler that's available on the Idun cartridge. So we use the Linux command, and we can just say Linux make. And it will run the cross compiler and build executables out of these C files. And then if we do a directory again, you'll see that we have not .com files, but .z80 files. And .z80 files are special because .z80 files, the command processor knows to load those onto the actual Z80 in your Commodore 128, assuming you're running on a Commodore 128. If you're running on a Commodore 64, this obviously is not going to work. But on the Commodore 128, these .z80 files want to run on the Z80 CPU, and it happens automatically if I just type, let's do draw 80. Then now we have this graphical program running on the internal Z80 using the VDC to present graphics. Something CPM can't usually do, but if you have in this case, a CPM program written specifically for the Commodore 128 for the VDC, and you compile it with ZCC, then you can do this kind of stuff. And we just press space to get back into CPM. And we'll also run a live 80. You might have seen this before if you watched my other video about developing and running code on the Z80 and the C128. So back into CPM, and we'll go back to volume C1. And another thing that's interesting with ZCC is it's not limited to just generating binaries specifically for the Commodore 128. You can also generate generic vanilla CPM binaries. So for example, this ANSI-test.c file, we can compile that for CPM by just doing Linux ZCC, and we specify plus CPM as the output format, plus CPM. And the name of the file, ANSI-test.c, and the output file we want, which is going to be capital ANSI-test.com. So we need to use all caps because the CPM files, as you see, they all follow the 8.3 11 character file name, and it's actually case insensitive. But when we use the Linux command, now we're operating on the Linux file system, and things are actually case sensitive there. So if you want to have an all caps file name that's going to be compatible with CPM, then you need to specify it as all caps when you use the Linux command. So press return, and just that quick, it's compiled, and then we can just run. Well, we're going to need to erase ANSI-test.z80 because we don't want to run that one, and that will be the one that runs by default. And now if we run ANSI-test, the CPM version, you'll see it just happens on the regular display. So it's a vanilla CPM program. You could copy it over to some other CPM system and it should run just the same there. So let's CLS to clear the screen, get rid of all that. So one more thing to demonstrate here is this VIC demo. So I have to move the camera a little bit so you can see the VIC display on the side as well. And then if I press Commodore 4, then we switch into the 40 column mode. And then I can just type VIC demo. And you see we're doing some fast text output directly to the VIC screen. Press return. Now we got some falling snow. This demo actually comes from the SG graphics library. So shout out to the author of that. I discovered this through my research into the ZCC compiler. This is part of the Z88DK development kit for writing software. I mean, ZCC works for all kinds of Z80 platforms. And some excellent code was created to demonstrate what you can do specifically with Commodore hardware with CP/M applications or C applications. Here's a little sprite moving across a character generated scrolling layer. And we got a bunch of sprites all moving smoothly across the screen. Not the type of thing you typically see from a CP/M program or from a modern C cross compiler running on a cartridge. So it's pretty neat and fun to play with. You should look at the demo code for this. It's very well written, easy to understand. And finally, we're going to draw some lines. You can see performance-wise, it's not quite assembly language speed, much faster than BASIC though. Rectangles, ellipses. Ellipses seem to draw pretty fast from C code. And then just a demonstration of foreground, background text, different colors for foregrounds and backgrounds. And then we're right back into CP/M, and if we press Commodore 8 to switch to the 80 column mode, then we'll be back over on the 80 column display. So obviously up to this point, I've just been demoing the CP/M on the Commodore 128 with mostly with the 80 column display. And now I've moved over to the Commodore 64 and want to show you what it looks like on this machine. So if we start it from BASIC using the go CP/M command, then the thing you're going to see right away is that it's not 40 columns. It's actually an 80 column display. If we type the SD command, you can see we got a nice wide 80 column directory display. And this is because we're doing kind of a hack that's been around for a long time, probably back to the mid 80s at least, where we use a bitmap VIC-II display to simulate 80 column text. And as you can see, it's not super readable, but it's readable, and it's not super fast, but it's not too bad. If I do SD command again so that it has to scroll, you'll see that it kind of jump scrolls. So it's not, not nearly as fast or smooth as the 80 column display on the C128, but still serviceable. And if we want to, for example, go into drive A2 and we'll run Zork1 again, it's quite usable, and you get the right formatting of the text. So if we do south, east, we'll find our way back into the kitchen again. Okay, so we're in the kitchen, and it's got this display of everything, or this text describing everything we see in the kitchen. If we just press Commodore 4, we can switch into the 40 column mode. And if I just issue the look command, then it will reprint the description of the kitchen. And as you can see, the line breaks are all in a weird place because it's designed for 80 column display. And this is the kind of hokiness that you get when you try to run CP/M software, even simple stuff like this, on the 40 column display. So usually you'll want to stay in the 80 column mode, like so. We'll quit out of this. And of course you can do the Linux command again. So if we do like Linux top, you can see that we'll have a nice dense 80 column display of Linux text, in this case just showing us running processes. So most stuff is serviceable. I'll show you something that's doesn't work so well. If we go to the C1 drive, there's the colon. All right, and we're going to use the Joe editor, and we'll look at this ANSI-test.c file. And so far it looks okay, and if I do like the Control KU to jump to the top, that's okay. We can kind of scroll around and edit this C program if we want to. It's not too bad, but you'll see the scrolling is kind of laggy. And then when we try to do stuff, for instance, like just to scroll up, you'll see that it scrolls first and then updates the display. If we um, scroll down by a page, so Control V, you'll see that it scrolls first and then refreshes the display. So, in this case, with the laggy scrolling, it's not super usable. But with normal, just rolling text, it's not bad. So I wouldn't suggest trying to use the 80 column display for an editor. So the last couple of things that I want to demonstrate will be done from a desktop computer. And here we are sitting at a terminal application. And one of the things you can do, based on the way CP/M has been implemented for the Idun cartridge, is you can connect to it remotely. So using SSH and just using the username CP/M at the IP address of your Idun cartridge, if you press return and provide the password, which default password is Idun, then it will log you in and drop you right into CP/M. So here we have all the same commands and capabilities that I was demonstrating before on the Commodores. But obviously you have the benefit of a nice, big, clear, modern display. And that makes a huge difference, especially compared to like the 80 column software 80 columns on the Commodore 64. For example, if we go back to the C1 directory and we again use the Joe editor to open that ANSI-test.c file, you can see now you have a nice fast-moving, fast-scrolling sort of environment, and it's a pleasure to use, just like you would expect on when you're able to connect from a modern PC. And of course, you can use other Linux programs too. If Joe is not your cup of Joe, so to speak, then you can, for example, use NVim or Nano, or my favorite is Micro. So we can also say like Linux Micro. ANSI-test.c, and now we have a kind of a more modern editor to use, and syntax highlighting, and yeah, just easy way to connect to the same file system and do all the same things. And only when you want to maybe run the program on the Commodore do you need to necessarily go back to that. The final thing I also wanted to show is using the Idun file browser to access your CP/M files. So if you go ahead to your IP address :8080, then you'll connect to the Idun cartridge through the file browser and just log in. And if you navigate to Idun base and then CP/M, here you find the A through E devices that we were using in CP/M. And if you want to navigate deeper, you'll find the user areas. And for example, if we go to C1 here, then we see the files we've been working with. For example, the ANSI-test.c file. And so it's another way we could edit it, is we could just open the file right here directly and edit within this browser window. And you can make changes and save them by pressing the little save icon up there. So that's another convenient way to edit files from remote. There's also drag and drop. So if you have, for example, this alive80.z80 file that we built and you want to move it to somewhere on your PC, you can just drag and drop it in the Finder window, or you can click the download button here and that will download it to your system. Another thing that's very useful, if we go to, let's say, the B1 volume, and this is where we have some turbo, I'm sorry, not B1, it's B0. We'll go to B0, and here we have some Pascal files and the Turbo Pascal compiler that we were playing with before. And if you scroll down, you'll see there's this PDF file. There's a manual.pdf, and actually many of the volumes have a PDF file. And if you just double click that, then right here in the browser from the Idun cartridge, it will open up the Turbo Pascal reference manual, and you can learn all about using it to your heart's content. So another very useful way to access information on the CP/M volumes. So that's everything I wanted to demonstrate today. I hope I've kind of piqued your interest and showed you some new and different and fun ways to utilize the CP/M operating system with your Commodore computers. And if you have any other interest questions about the Idun cartridge, definitely check out the links in the description below. Have a good one.